Hey everybody, and welcome to our Code Presents webinar for the day. This is going to be Secure Web Services. We're excited to have Alex Pirker presenting for us today. This is going to be a really interesting session. My name is Jim Duffy. I'm in charge of marketing and sales and all that good stuff here for all our code services, including Code Magazine, of course. But Code is so much more than just a magazine. Our primary mission is simple. We help people build better software. We're a certified partner. We do custom software development on the web, the cloud, mobile, desktop, lots of different platforms. We also do a bunch of project rescue and app modernization. We modernize legacy applications built in like Visual Basic, Microsoft Access, Fox Pro, ASP Classic, even old WinForms applications. So if there's anything you've got an old application and you need to get modernized, we can certainly help with that. We can also help augment your development team as well with our code staffing initiative. Just give us a call and let us know if we can help you. We also have a free ticket to consulting here. This is a very popular service we provide. It's literally 1 hour on us. No schedule, just schedule a call. There's no strings, no commitment, no credit card required. Just get help from us. You schedule a call and we can spend an hour or so on a call with you and answer whatever questions you need for whatever you need answered at complimentary. Just reach out to me at jduffy@codemag.com. Slots are limited, so reach out and we'll get you scheduled. They can come join us on the Code Consulting team. We are hiring developers. We have current openings for data engineer and Python developer, React developer, and JavaScript developers, senior C#, if I could learn how to talk, .NET developer, a desktop developer. So you can just go to codemag.com/jobs and find out what we have available. We'd love to have you join our team. Of course, we'd like you to join us on social media, join us on our YouTube channel, follow us on Twitter, like us on Facebook, and like us on LinkedIn. Connect with us on LinkedIn. We'd love to have you in our social media circle. And every attendee here is going to get a free subscription to Code Magazine, a digital subscription. If you're not already a subscriber, you get a free digital subscription to Code Magazine just for being a registered attendee. If you've got people who you think would be interested in a Code Magazine subscription, like maybe your Twitter followers, feel free to share this link below here. We'll make sure that link is also in the chat window so you can share that with others who could make it to the webinar today. The Code mobile app is available on both iOS and Android. It's the ideal way to read Code Magazine on the go. We also have a free coronavirus subscription available for all of our desktop, all of our subscriptions. Our magazine's going back for the last year or so, so go ahead and check that out as well. We have an event survey. This is really simple. It's about 12 questions. We'd love to get your feedback on this event. Here's a link for it right there on the screen. In order to be qualified for a $100 Amazon e-card, because we will give away a $100 Amazon e-card to a survey, it's got to be filled out by basically midnight Friday night on Friday. So complete a survey, and you may be the one who scores a free Amazon $100 e-card. We also have a platform we're very interested in, very active in. It's an open source platform called Photino. It's a framework for building native cross-platform desktop applications using your HTML and CSS skills. It's maintained by the Code Magazine team with the help of the open source community. Give it a look at tryphotino.io. If you're looking to build cross-platform applications on the Mac, Linux, Windows, Photino will be the way to go. The recording for this webinar and all of our webinars, for that matter, is available on our stateof.net and Code Presents web pages. You go check them out right there, and you can find all of our prior webinars and slides for all the prior webinars as well, all the recordings. About the presenter, Alex Pirker is a senior security consultant. He's also a code author. I've put a link there to his most recent article for us about secure microservices, which, surprise, is what he's talking about today. It comes from our March and April 2022 issue. Alex is a smart guy. He's got a PhD in physics. He's also got a master's degree in technical mathematics and a master's degree in biomedical informatics. Boy, if I could learn to talk, that'd be dangerous. And also, in order to get through all the material today, we're going to ask that all your questions be posted in the chat window, and we're going to try to get to them all at the end of the session. So we make sure that Alex gets through all his content, and then he'll answer any questions that you have at the end of the session. If this is your first time attending one of our webinars, welcome. Thank you so much for joining us. This is awesome. If you've attended one of our webinars in the past, welcome back. We enjoy have repeat business here, have you come check out more of our webinars. Thanks for listening and enjoy the webinar. Alex, turning it over to you.
Okay, thanks for the introduction. I will just bring up the slides. Here we go. Looks good?
Yes, looks awesome.
Okay, great. Okay, first of all, thanks, Jim, for the introduction, and thanks also, of course, for giving me the opportunity to speak here today in terms of this webinar. The topic, secure microservices, I wrote an article about it quite some months ago already, where I wanted to highlight some of the common mistakes and also some of the common protection techniques against certain attacks for microservices. And what we are going to go through today is a little bit leaned on also on the article itself, because for the article I use as a cover up, so to say, a medieval town as comparison. That's why you may read down or who talks to who about what. But let's get concrete. First, I will give a short introduction about the topic itself. So, what is it about? What is the general setting? And then I will talk about the so-called down. By down here, I mean your cloud environment, your cloud infrastructure, how everything is deployed. Then next up, it will be a lot about communication also, because communication is one of the vital parts in a microservice architecture. I guess the software engineers here and also the architects, they are quite aware of it. And it's very important to know actually who is talking to who about what. Next up, we're going to talk about authentication, authorization, tokens under the umbrella term knock knock who's there, because it has a lot to do with identity also. Next up, I'm going to talk about container security and pod security, but also about input data to your services. So this part I huff and puff to blow down your own will be a lot about your individual services, how to protect an individual service from attacks. What can you do at this level, at the level of a Docker image, for instance, or at the level of a pod, or even in the service implementation. And finally, I also want to talk a little bit about how to hide secrets. So how to hide your treasure. By treasure, I mean passwords, cryptographic keys, something similar which relates in this direction. Okay, so what's the plan? First, of course, I need to introduce myself also a bit. So my name is Alexander Pirker, as we had heard it before already. I'm senior security consultant. And my daily work basically consists of penetration testing. I do a lot of security reviews and code audits also. But I'm also doing quite a lot of cryptography reviews. So if there are some special implementations of, let's say, elliptic curve cryptography, for instance, and this needs to get checked for side channel attacks or similar, then I'm also doing that kind of stuff. I also give secure coding trainings, and I also do some architectural consulting and custom development. Okay, a funny picture. I thought I'm gonna start this entire session today with two images which I want to compare, and for the purpose I've chosen our pets at home. These are tortoises, and I want to relate the picture how secure you think you are and how secure you really are. Here on the first one, we see how secure you think you are most of the time. Tortoises, I mean, many people believe that they are very, very robust, that they are very, very secure. And this is also most of the time what happens to developers and in general engineers. You believe that you are so secure as a tortoise. They've got a nice protection shell. They are covered from outside threats. It's very hard to get in. It's hard to crack. So for an attack, it's really, really hard to do something. However, there is one big thing about it. Most of the time, when a tortoise turns upside down, then it's very hard for them to get back on their feet again, especially if the floor is quite slippery. It's almost close to impossible. So they will try to use their legs in order to flip upside down again and to get in a normal state, in a healthy state again. However, as soon as they enter this upside down state on the floor, where it's very, very clean and nice surface, so to say, where a slippery surface, then it's very, very hard to turn for them around again. And this is most of the time how secure systems, at least backend systems and also front-end applications, which I audit, how secure they really are. So they are more like a tortoise upside down. So they believe they are very secure. However, if you take a closer look, especially at the level of source code, then most of the time it turns out that they are not as secure as they think. But of course, we need to ask ourselves also, why should we consider security in the first place? I mean, we can also say, okay, security, nah, it costs too much. It's a pain in the ass. We need to spend a lot of effort, right? So why should we consider it? And I want to highlight two quite recent vulnerabilities which have been disclosed and which have hit actually the Java world quite hard. The first one is the so-called log4shell vulnerability. It was discovered in the log4j framework. It's a critical remote code execution vulnerability. By remote code execution, I made a small diagram there where you can see it also. Remote code execution means, simplified speaking, that you've got a malicious application, you send some form of dangerous payload to a vulnerable backend. The payload contains here, in that case, some form of script code that may be really shell commands, for instance, for a Linux shell or so. And the vulnerable backend just simply executes this script code. This, of course, gives the attacker, I would say, the most access to a system he can get at all, because depending on which user is running the backend application, this may result in a full compromise. And one of these vulnerabilities have been found in this log4j framework, and the small research actually revealed that around 40% of all networks globally were vulnerable to this issue, which is an extremely high number, and this costs a lot of money. The second vulnerability, which I wanted to highlight, is the so-called Spring4Shell vulnerability. It's again a remote code execution vulnerability. Now, in contrast, in the Spring framework, for you who are not maybe aware of it, I mean, Spring is used nowadays by almost all Java applications, I would say. It's quite standard. However, if you're not familiar with Java, Spring is basically a framework on top of which you can build backend applications. And there was also a remote code execution vulnerability found, and this impacted 28% of all software vendors globally. So as you can see, this is actually quite problematic, and so you should consider security in the first place. But now let's turn on a bit to the setting of this entire webinar. So we're going to talk about microservice, or I'm going to talk about microservice. And I decided to use one of these very famous pictures from Microsoft, the eShop on Containers reference application, which depicts somehow a typical microservice architecture. You've got several front-end applications, like for instance, a mobile app, maybe written in some forms, C# or whatever. You've got a web app, you've maybe got even a desktop application. However, all these applications need to access some form of backend. Usually, they do that by talking directly to an API gateway. The API gateway then decides, okay, to which services do I need to forward? It may also already provide some basic security checks. And then in the backend itself, you've got tons of microservices running. These microservices are acting like silos, so to say. They come most of the time with the individual databases. And they communicate also either via an event pass or maybe even directly. And this is our setting, which we're going to talk about today. So let's talk about the cloud backend. What is the current situation? At the moment, there is actually a very big shift, so to say. And the shift is, of course, in the entire community towards cloud. And of course, the most prominent cloud provider, I would say, is certainly AWS, Microsoft, there's also Google, there is also an Alibaba cloud. There are maybe also tons of other ones. However, there are many, many cloud providers out there. And why should you actually move to the cloud? I mean, there must be a reason for that, why everyone is jumping on the train. And I would say two very good reasons is if you host your own infrastructure, it's a lot of work. It's a lot of work. It's painful. You need to set up everything on your own. You need to configure everything on your own. You need to keep it running. You need to maintain it. You maybe even need to change hardware at some point, and it may also be expensive. So there is a movement in the entire development community in the software industry towards cloud, and that for a good reason, of course. But this also comes with some prices. And the prices are, of course, here also, how is this going to be attacked? So if you think of the cloud system, which I just outlined before in the beginning, this eShop on containers, how does it look like from the outside to an attacker? I mean, it looks like a black box. There is a cloud, there is some form of backend inside. The backend will receive some form of inbound traffic, right? So the situation is the following. The attacker controls the inbound traffic, of course, because he can decide what he wants to say, what he wants to send to the backend. Potentially also, the backend will also communicate to some outside services, so there will also be some outbound traffic maybe. There may be some management interfaces because one of the DevOps engineers maybe need to set up the entire cloud environment in the very first place. And very important also, maybe the attacker even has some knowledge about how this backend itself is structured. I mean, there are tons of GitHub repositories which contain a lot of source code of backend systems. So he may also have some insights how backend is structured. So this is the full picture. You've got you've got multiple applications. They maybe even have some API tokens associated for the communication. You've got an API gateway. The API gateway then routes the requests to the individual's microservices, like here, for instance, billing service, shipping service, order service. Each of these services comes, of course, with its own database, as it's quite common in microservice architecture. And then you've got two interfaces at the bottom. The first one is the management access, which may be used by the DevOps engineers. And then we've got external communications. So these are actually these three interface points: the API gateway, the external communications, the outbound traffic, and also the management access. All three of them may be subject to an attack. Because, of course, an attacker can provide malicious input. He can provide some form of unexpected requests, or may even try to get to endpoints which do not require authentication or similar. So he can control the inbound traffic, that is for sure. However, depending on the strength of the attacker, think of a nation-state attacker, for instance, an attacker could even control outbound services. In that sense, I mean, he may be even able to maybe middle connections, depending, of course, on the security settings. So in general, this is extremely hard and not achievable. However, sometimes it needs to be taken into account also. So the attacker may also be able to control somehow the outbound traffic, at least a little bit. So this means that he could provide malicious responses, which contain some form of malicious payload, so to say, which is then interpreted as services. And finally, an attacker could also try to simply directly access the cloud system and just simply modify components on the fly. He may simply go there. If he is able to log into your AWS environment, he can just simply remove your Kubernetes cluster. He can alter the database, etc. So as soon as he has access to the cloud provider itself, I would say it's quite game over, because then he can remove everything what he wants. So what are we going to talk about today here in part of this webinar? I've decided that I will center, I would say, the entire presentation. Yes, it's basically the entire presentation almost. Will be about inbound traffic. However, what you can do about, for instance, to protect against attackers providing malicious responses. Of course, as I said before, you can try to parse and evaluate results from external services. You can try to use, or you should use, of course, always authenticated connections only, so never plain text connections, so never HTTP, always use HTTPS, for instance. And in order to protect also your management access, of course, the most important thing there is certainly management access in terms of role-based access control, that you define, okay, which operator has access to your cloud environment, which operator is allowed to perform which kind of operations so you just simply grant, maybe even based on role concepts, what kind of operations an operator is allowed to perform within your cloud environment. So we said we're going to talk today about the security of the inbound traffic of microservices, but this also involves a lot of communication. And I would like to start this entire security discussion with who talks to who about what. And I want to start this entire part by highlighting the communication problem in general, without talking about solutions, just about communication of computer systems. So the main issue is the following. Suppose that you've got a client, and the client wants to talk to a server. Of course, he doesn't verify the identity by default. In that case, the client cannot distinguish between someone in the middle, because the client may think he talks to the server because he did not verify anything. So the client may want to talk to server, but in fact, he talks to the middle, which then forwards it again to server. This has a severe issue, of course, since middle is then able to gain all the information which client wants to send to the server. But what is here really the underlying problem? And I would say that here in that case, the problem is that communications usually build around trust, because you believe the person or the service you are talking to is really the service who it's intended to be. But without verifying that, you can never be sure. So you need to verify that. And this very, very closely relates to so-called man-in-the-middle attacks, where, as in this picture shown, as in this image shown, that a client may even want to talk to server. However, in fact, he talks to middle, which then talks to server. And thereby middle gets all the information, of course. So this is the problem setting, so to say. How can we solve this issue? I mean, if we would just simply think about real life, of course, it's always about how to make sure that someone is the person or the entity he pretends to be. And I mean, we, society, we solve this issue, I would say, by simply creating the notion of a passport. The passport, in that case, gets signed by a trusted authority. It gets issued by a trusted authority. There is your name on it, there's your birth date on it, some other information. And this gets then signed by a trusted party, by a trusted authority, here in that case, the United States, in case of this passport. And everyone believes, in that case, this nation state, and therefore this passport is considered as something valid, which issues the identity of a person. So we solved the issue, so to say, in the real world. So how would we do that now with services and computer systems? And there exists a standard for that. There exist solutions for that. They are all summarized under the umbrella term public key infrastructures and asymmetric crypto systems in principle. So what to do in order to build trust between a client and server is the client needs to check somehow the identity of the server. And the identity of the server can be checked by using certificates. In that case, X509 certificates. These certificates, they basically build around public and private key pairs. The certificate itself contains the public key. It also contains some other information like a name, a date when it expires, etc. So the certificate is in principle a wrapper for the public key of an identity of an entity, together with some descriptive information. And now comes the most important part. The certificate gets signed by a trusted authority. So there are several trusted authorities out there. I think no, I don't remember now one, but there are several of them. There are several trusted authorities out there, and these trusted authorities then they provide a signature underneath this public key by which they certify somehow the valid identity of this server. And the cool thing about it is that this enables actually clients to verify these certificates, since the certificate authority or the trusted authority uses its private key in order to sign a certificate, and the client can use the public key of this trusted authority in order to verify the correctness of the signature, which is quite cool because the public key is public, so everyone can read it. There is absolutely no other problem. It's not a secret or so. But it gives the client the possibility to perfectly make sure that the server is really, or the certificate of the server at least, is really signed by this trusted authority, and thereby verifying the identity of the server. And underneath the hood, this is what builds around TLS, around HTTPS connections. So these TLS connections, they use certificates in order to establish trust between a client and the server, and in order to ensure or to check identities. How does this now map to our microservice world? Because of course the entire webinar is about microservices. So how does this now map to microservices? And for that purpose, we need to distinguish two different kinds of communications in a microservice architecture. The first type is so-called orchestration, and the second one is choreography. In orchestration, the services communicate directly to each other. Like for instance, here in the picture, billing service talks directly to shipping service, which directly talks to order service, for example. And If you want to use TLS, then of course you need to create everywhere TLS connections between all these services. However, the communication is direct between services. In contrast, if you've got a choreography-based microservice architecture, then all the services will talk to a messaging system. This may be some form of event bus system. There are tons of different implementations out there, like for instance, RabbitMQ. And the services establish TLS connections, so secure connections, because TLS connections also encrypt all the traffic. So these are really secure connections, since TLS offers confidentiality and integrity. Confidentiality means that no unintended party is able to read the communication on the wire. And integrity makes sure that an unauthorized party cannot change your traffic without the recipient noticing. So you have some form of legitimacy of the content when you receive it through a TLS connection. So TLS helps you really a lot in your microservice architecture to establish security, since it helps to build trust, it provides confidentiality of communication, and it also ensures integrity. So we've got these two different types. And the solutions to these communication problems, if you go with orchestration, then, as mentioned before, you have a service-to-service trust relation in that case, which may be harder to maintain and also harder to implement, because the services communicate as they need. So you will need a lot of certificates flying around, a lot of validation going on all the time. Whereas in a choreography-based microservice architecture, the services communicate via messaging system. And also the trust situation is different then, since there is only a service to message system trust, since the services need to trust the certificate of message system, maybe even the other way around also. It's also possible. However, in a choreography based microservice architecture, you've got the central point of failure, which is not so appealing from a architectural perspective, of course. However, you can also have fail safes and failover strategies in order to compensate for that. However, it is some form of a central point of failure. So, okay, we are good, right? Our communication is solved. So we can put aside our communication problem. Actually not, no, unfortunately. Since imagine you've got 200 microservices. So you've got not only 3, as in the previous slides. Suppose that you've got 200 microservices running potentially even in different namespaces of a Kubernetes cluster. Since nowadays, all these microservice architectures, they most of the time at least, they build around Kubernetes, meaning that each service corresponds to multiple pods potentially, and you can separate it by namespaces. So what to do in this situation if you've got 200 of these guys running in different namespaces? And I want to highlight one of the features of Kubernetes, which is, in my opinion, one of the most underused, but one of the most important features. And this is network policies. And suppose, like in this image shown, suppose that you've got 4 services. Service 1 talks a lot to service 2, and service 1 also talks a little bit to service 3. However, service 3 and 4, they talk again a lot. And the communication from service 1 to service 4 and from service 2 to service 3 and 4 is not allowed at all. It's prohibited that these services talk to each other. In a standard Kubernetes cluster, you cannot really prohibit that, since you did not, you cannot apply some form of network policies. However, if you separate these services into dedicated namespaces, then you can make sure via network policies that this communication, which should not be allowed, is not taking place in the first place. Because a network policy separates the networking in a Kubernetes cluster at level 3 or layer 3 and layer 4 of the OSI model. And for that purpose, you can define rules for this separation. And this works in the following way. You can define in a Kubernetes cluster so-called ingress rules, which define what enters the namespace, so what is going into the namespace. You can define this really at the level of IP addresses, or even at the level of ports if you would like to, which is quite a good practice, to be honest. Since if you know your services only listen to, for instance, 8080, to port 8080, then there is no reason to expose, for instance, port 22 or any other port. There is no reason for that. It just opens up the attack surface unnecessarily, so you can close it down to really what is open. These are ingress rules. But you can define the same also for outbound traffic, which is then summarized under the term egress rules. And here again, you can define to which endpoints or to which IP addresses, to which hosts, all pods within the namespace are allowed to talk. So this is then really defining outbound rules for your Kubernetes namespace. Okay, communication, we can put aside. Let's attack the next issue. Now let's talk about identity. Of course, we enter again the trust problem. Because how do you make sure that the user is really who the user pretends to be? I mean, how can you be sure that me, Alex, is really accessing the backend? How to implement that? Because somehow you need to implement that. And of course, simple solution, let's authenticate. And I've depicted here I would say, quite standard workflow for authentication. And it works the following way. You've got a client application which talks or which has to talk to some form of a backend. And in order to trigger the authentication, the client first needs to log in. By login, he provides user ID and password. He sends this information to the backend. The backend checks these credentials. It checks whether I really got the correct password. And if that's the case, then I generate a so-called JWT. JWT stands for JSON Web Token. So never say JWT token because this doesn't make too much sense. So JWT. And if the credentials are correct, then a so-called JWT is generated. A JWT consists of multiple parts. It has a header. In the header, there is the version, there is the algorithm used for the signature. Then there is a so-called claims body part. In the claims body part, the backend puts the identity of the user usually in terms of an ID or email address, but it may also put some claims into it. It may also say, okay, Alexander Pirker, he is an administrator. He is allowed to read, update, delete, and create, for instance, new users. And then the backend puts these kind of claims, these kind of permissions into the body of the JWT. And finally, the backend signs this JWT and provides a cryptographic signature with a secret key. Of course, then in the end, the backend, after correctly authenticating the user, returns this JWT back to the client. And now, from now on, the client needs to pass through in each and every request this JWT for the backend, which then verifies this JWT with regards to correctness. This can be easily checked by this signature. And in case that this signature is wrong, then the backend just simply stops the processing and says, okay, you're not authenticated. This is possible since a signature, a cryptographic signature, makes sure that here in this particular example, that header and the claims body part of the token have not been changed by some attacker on the fly. So as soon as you've got a cryptographic signature underneath header and body, so claims part of the JWT, it's really made sure that these values in claims and body cannot be altered by an attacker without the backend noticing. So this is the cool feature about it. Okay, so tokens usually then also have a claim, which means expiration. So tokens expire. And this is now, of course, quite a complicated situation because you don't want your client to all the time retype his password in the client application in order to get a new access token. It's not fun. The user experience goes to hell, and no one wants to do that. So what people then started to do is they invented so-called refresh tokens. And the idea of a refresh token is the following. It's basically the same story as with a JWT with an access token. However, the expiration date of the refresh token is simply much, much higher. So for instance, the JWT access, this one is valid for 1 hour maybe, it expires. However, the client application gets at the same time on successful login also a refresh token, which is valid maybe for 2 hours. Then, as soon as this access token expires, the client just simply takes the refresh token, sends the refresh token to a refresh endpoint on the backend. The backend validates, of course, the refresh token. And now comes a very important step, which is very often overseen. The backend revokes both tokens. So it needs to really make sure that this access token 1 and the refresh token 1 are no longer considered valid. This is important because, for instance, suppose that you refresh the token already after 10 minutes. May happen. In that case, if your access token is valid for 1 hour and the access token leaks in the next 50 minutes, then an attacker could use this access token in the next 50 minutes in order to talk to the backend. And this is not what we want, right? We want that access token 1 and refresh token 1 are no longer valid as soon as refresh token 1 has been used. Therefore, you need to revoke it. You can put it on a deny list or delete it from the database. However, you need to make sure that this token is revoked and no longer accepted by the backend. And of course, since we had a valid refresh token, the third step and last step is we generate a new pair of access token and refresh token, and we return it to the client. And our problem is solved. So who is now responsible for authentication? I mean, this is quite a philosophical discussion almost, because there are several different ways how to implement that. And all of these implementations have their pros and cons. I wanted to highlight two different ways how to do it. And the first one is to have an external provider, like for instance, Auth0 or so. The second one is that you implement your own authentication service. However, the workflow is quite similar in both of them, because you just simply log in either to the provider or to the authentication service, which then provides you in return with JWT in case that you were successfully authenticating. And starting from that point on, the client application sends the JWT together with every request to the backend. And the backend makes sure and verifies on each and every request that the JWT is first of all valid, it's not expired, the user still exists, etc., etc. So it makes sure that everything is really safe. And only upon that, the backend really processes the request. Of course, in order to verify the JWT, the backend either needs to get the verification keys from the provider in order to make sure, okay, everything has been signed properly by this trusted provider. Or of course, if you host your own backend, then someone need to make sure that this signing key is properly mapped into the service who really checks the JWT tokens in order to verify it. Okay, if this is still not secure enough, and this may be the case depending on the application what you are writing, there are even further protection techniques when it comes to protecting your backend from unwilling access from someone who you don't want to have on your backend. And I wanted to highlight one of these approaches, and that would be access control lists. So you can, for instance, for mission critical services, you can even control the access to your service by access control lists. You simply list a certain set of IP addresses, for instance, which are allowed to get access to your service. This you can implement in the following way, as depicted on the picture. You've got a client application which talks to an API gateway. Let's consider, for instance, that it wants to talk to the get users endpoint. Client has IP1. And then as part of the normal request already, the client provides the HTTP header together with the authorization header. However, the API gateway now performs an additional header enrichment, so to say. So it puts also the IP address of the caller into the header. This is also maybe you came across this even. It's this X forwarded 4, for instance. This is also one of the common HTTP headers which are used for that. However, the API gateway simply puts the IP address of the caller into the headers, and then forwards the entire HTTP request together with this new header to a service, and the service can then simply extract the IP address from this header and just simply check it against a control list, against an allow list. If it's there, the IP address, in that case it is, IP1 is in the access control list database, then the client gets access to the service, otherwise it gets denied. And this is just simply an additional technique which you can put on top of all the existing techniques which we've seen so far with regards to authentication and authorization. How could this now look like in terms of a middleware pipeline? Because this is, of course, very interesting if you work with ASP.NET, for instance. Then you could have multiple middlewares in place in each service, for example. You could implement it in the following way, that you've got first an exception middleware. I will talk about this very, very soon. So you've got an exception middleware, which invokes an authentication middleware, which checks the access token, which invokes again an authorization middleware, which checks all the claims of the token, which then maybe checks an IP address in an access control list middleware. And then you implement the domain logic. And then, of course, the request passes upwards the stack again, the other way around. And all these middleware layers, they build on top of each other. So what is now this exception middleware, and why is this very important actually? Suppose that you don't have an exception middleware. Suppose that you just simply propagate exceptions downwards to the client application. Let's say, for example, that you've got an endpoint, a get users endpoint, where you provide an user ID, for instance, as a HTTP parameter in the route, and suppose that the service tries to locate the user within a MySQL database also. However, the user is not found, and for some reason, we get a MySQL exception thrown. If you do not catch this exception, it may get mapped directly into a HTTP response, which then gets sent back to the client. However, notice, and this is very important, that this leaks actually quite some interesting implementation details about service to an attacker. Since the attacker knows from that point on that this service, which he is hitting right now at the moment, which he's attacking at the moment, is using a MySQL database in the background, this means that if he wants to try to inject something, then he may try to go for SQL injection attacks. So this provides some interesting information to an attacker, which you do not want to leak. So you should implement an exception middleware which catches these exceptions, translates it into HTTP response codes, and make sure that you do not leak any form of implementation details to the client application or to a potential attacker. Okay, but now enough for identity. We have heard it now twice. Now we move on. Now we want to talk about container security and about service security in general, bot security, etc. So how to harden your microservices from bottom up, so to say. What else can we do? As I said, we attack the authentication problem. We know the users are who they pretend to be. We are sure about the communications inside and externally of the cluster. But we did not talk about individual services. What can we do there? There are actually some things what you can do when it comes to container and bot security. And this is just a small excerpt of, I would say, best practices which you should consider. If you have a service potentially built using Docker and you run it in Kubernetes as a pod, then you've got already two tools involved, Docker and Kubernetes, which utilize some or which are required for your application to run, because your application itself is stored inside a Docker container. So you've got these two additional layers around your application, right? And there are a lot of things to consider. First of all, and this is important, never run a container as root. This is very, very important. You can drop the user in your Docker build that the application does not even start as root user. Since root on Linux is extremely dangerous and you should never run any form of application unless you really require it as root. So you should always try to run your applications as non-root user. And I know this is sometimes hard because applications build around data and around files, at least many times. Try to run the container with a file system which is read-only, because even in case that an attacker somehow makes it inside the container, which is hard to achieve but possible sometimes, then at least the attacker is not able to modify files within your container, within your application container. So this would be one hardening measure, so to say. Of course, no privilege escalation. I mean, this is self-speaking. If you run your container or your application as app user, so to say, and you can escalate privileges to root, then yeah, it's not really helpful. So you should also prevent privilege escalations, of course. And the next 3 points are actually extremely important, because this I've seen quite recently. Isolation from the host file system. I've seen it multiple times that some microservice applications, especially when Kubernetes is hosted in-house, they get access to the host file system. And this is extremely dangerous. Suppose that you map the var run directory inside a pod, inside a container in Kubernetes with read-write access. Then this pod or this container is able to write into the host file system, into the host var run directory, and he is maybe even able to access all the data which is stored there, like sockets, like for instance, Docker is persisting his sockets there under var run docker sock. So if you are root user and you get access to a host file system, this can be extremely dangerous. So this is something that you should certainly prevent. The next point is isolation from the host network. Also very important because you don't want your containers to break out and talk to other computers or to other servers within the same host network, because they should be isolated. Actually, the Kubernetes containers and the pods, they should be isolated from the host network totally. So they should not be able to reach any host outside unless, of course, allowed by endpoints. Then Kubernetes per default maps the service account tokens into each pod, which can be extremely dangerous, since if you manage to get into a container, then you can inspect this service account token. And this service account token, depending on your RBRC, so depending on your role-based access control in Kubernetes, it may allow an attacker which is inside a container to use this service token to talk to Kubernetes API server. And by that, depending on RBRC, he may even be able to launch new pods, to alter config maps, to read out secrets, etc. And this is extremely dangerous when you've got a container running and the container is compromised for whatever reason, and you mount this service account token into the container, because this enables an attacker to use this token to talk to the Kubernetes API server. And by that, he may cause really severe damage in the cluster by shutting down services, shutting down pods, altering config maps, etc. So this is also considered very bad. So don't auto mount service tokens. Okay. So what is more? Actually, we've got services which have input data. And I want to show with two examples how dangerous input data can be. First one is the following scenario. Suppose that you've got a client application. It's maybe some form of social media platform where you write posts, and the vendor or the software company which is hosting this social media platform, they maybe don't want to have political terms in their platform. So what they may consider is that they implement a so-called sensor microservice, which takes your entire post, it takes all the terms and filters all the terms against a known database where there are a lot of words in it which they do not want to see on the social media platform. For instance, politics, nation states, whatever. There are some terms which should not appear. So in this setting, the social media platform, our client application, sends a request to our sensor microservice. It has a post like "Hello World," provides also the language. Here in that case, it's English. It sends this information to the sensor microservice. The sensor microservice splits all these terms in the post apart. It creates a collection, creates an array out of it. So we've got the array "Hello World" and the language, which is English. And then the sensor microservice needs to use a command line tool called filter tool. And this filter tool will talk then to a terms database where all the terms which are not allowed or prohibited are enumerated. And the sensor microservice invokes this command line tool really by constructing a command line. So assume that the sensor microservice is written in Python. We've got a filter function. And the filter function takes these terms and the language. The first thing what this filter function does is it joins all the terms with a colon, and then it constructs the command line. The command line looks like filter tool dash terms, where we then interpolate the terms, dash language, where we interpolate the language, and then since we need to invoke a command line, we perform a subprocess.run, where we provide the command and we execute it on the shell. The backend, the sensor microservice, then gets as a result the reconstructed post or the censored post, which it puts ultimately into the post microservice. Looks good. It's straightforward, easy to implement, and easy to follow. However, there is one big issue with that, and I want to highlight this. And it's the following. Suppose that an attacker crafts two payloads. In the first one, he provides in the language, instead of English, he provides English semicolon, and then he provides ncat-l-p 1111. Of course, here I'm assuming that port 1111 is open, since what this does on the backend is the following. The filter function will interpolate this new language simply into our CMD command line string. So we have then filter tool dash terms dash language, English, semicolon, ncat-l-p, and so on. By that, actually, the backend application opens a port on 1111. Now, of course, here I'm assuming that this port is open on the backend application. If the attacker now sends a second payload, where he contains or where he sends in languages English, semicolon, and then this other term there, he makes sure that he gets a reverse shell, since this command then redirects everything which comes on 11.11 directly to bash, to the bash console, and by that an attacker has opened a reverse shell, and depending of course on which use this application is running, this sensor microservice, if it's running as root, then you've got a full compromise of your backend application, since the attacker has a reverse root shell open onto your backend. So you've got an issue. But maybe this was just one example, which is not so important, and maybe we don't need to care. So I want to point out another one. This application now is written in Golang, and it's about banking. So suppose that you've got a client application, a banking application, in which you need to register first with a public key of a user to a key microservice. So you provide a public key, here in that case, the public key of USA, which is of length 32 bytes, since we use ED25519 as elliptic curve for cryptography. So when user A registers, he sends his public key, 32 bytes, to the backend application, to a key microservice, and the store function just simply puts this public key together with the ID into the database. It's the responsibility of the key microservice. Get a key associated with an ID, store it in the database. So far, so good. Now, the client application, if the client wants to create a transaction, so let's say A wants to send 50 to B, whatever 50 means, $50, €50, 50 Bitcoins if he is wealthy. He wants to send 50 to B. Then what he does is he creates a transaction. He puts himself as the sender ID, so he puts the sender ID of user A into the transaction and signs this whole transaction with his private key. So he provides a signature underneath this transaction. Then, in order to settle the transaction, he sends the whole transaction to the backend, to a transaction microservice. And this transaction microservice has a validate function. And then in the validate function, the transaction microservice first looks up the public key of user A by talking to the key microservice. So he sends a request to the key microservice, hey, give me the public key of user A. Key microservice does its job. It returns this key, looks it up in the database, and returns the public key array, returns it to the transaction microservice, and this service then uses the key together with the transaction and the signature in order to verify the signature. With this ED25519 implementation from Golang, from the package, and if everything is valid and properly signed, the transaction is settled. Looks absolutely straightforward. There is absolutely no issue which you could spot here. The issue actually, and yes, we've got again an issue, here comes from a third-party dependency. Since suppose the following, suppose that an attacker registers with a public key which is less than 32 bytes. The key microservice doesn't care. He doesn't validate. He does what the key microservice is told to do, and this means storing a public key in a database. So he stores the public key without validation in the database of the attacker, let's say 10 bytes only. Then the attacker creates a transaction. He wants to send 50 to B. In that case, he puts himself, of course, as a sender, since he initiates the transaction, and he provides a dummy signature underneath this transaction. It doesn't need to even be a proper one. He can just send an array with all zeros. Now, this entire transaction gets sent to the transaction microservice. It enters in the validate function. The validate function, again, first goes to the key microservice, gets the public key of the attacker in that case, our 10-byte key, and feeds now all this information into the ED25519 verify function. And if someone takes a closer look at this implementation there, then you will notice that actually the verify function of this ED25519 has a quite severe issue. And this is the following. First, it gets the public key length from the public key provided by the invoker. And if that length of this array is not the expected one, we've got a panic. And the panic in Golang means that the process is gone if you do not have a recovery handler outside catching this panic. Here in that case, it's not the case. There is no panic handler, no recovery handler, which means that an attacker can simply bring your entire banking application out of service into a denial of service situation by just registering with a key which is less than 32 bytes. And he can do this permanently. He can, even if you have got Kubernetes in place, which automatically restarts the transaction microservice, etc., As soon as the service spins up again, the attacker sends the same transaction, and it will again take down your transaction microservice, which means that your banking application is out of service, and no one of the other customers is able to settle transactions anymore, which is quite a problem, I would say. So what you can do about it is, of course, you need to handle that situation and handle the panic. So in summary, missing input data sanitation leads to multiple issues, and I've enumerated some of them here, like, for instance, injection attacks, remote code execution, argument injection, SQL injection. But also denial of service situations, like, for instance, we've seen it with panics. Also, unhandled exceptions are a similar problem, but may also lead to information leakage. This now is more about C and C++, so with regards to programming languages where the programmer needs to manually manage the memory, because there it may be the case that you are able to read out of bounds, so from the stack memory, or even write out of bounds if you do not check the boundaries of your allocations. But this is not for the client side, cross-site scripting, for instance. It's also very often due to missing input data sanitation. So of course, solution, let's sanitize the data. And this is quite easy. As soon as you think about it closer, it's very easy. And the reason is the following. Since you know which kind of data you are expecting, are you expecting an enum? Like, for instance, with the filter tool before, or we got provided a language. A language cannot be arbitrary. We expect a certain enumeration of languages, right? The languages which our database supports. Let's say, for example, English, German, French, Spanish, etc. So we know which kind of values we expect. But also with integers, it's the same story. Is it a positive integer? Is it a negative integer? Is it maybe even bound within an interval? You know these things, so you know which kind of data you are getting here. Also date time. Most prominently with strings. Is the string a name? Is it an email address? Is it going to be shown somewhere later? Is it an account name? Is it an address? You know which kind of information you get within a string. And also one thing, because I did not know onto which slide I should put it as, make sure that you don't send sensitive information through URLs, like this example here, like get/users user ID equals user ID, and access token equals access token. The reason for this is the following: many proxy servers and many web servers log by default the URLs which are accessing the backend, and therefore you would have an information leakage, since if it logs the access token of a user, then this is really sensitive information. So don't construct or don't send secret information in that way. Okay, let's move to the last. Secrets, cryptographic keys, and especially where to store them securely. There are, I would say, I have highlighted here now 5 different options where you can provide secrets or where you can store secrets, because at some point every service or most services, they will require some form of secrets. Maybe they need to sign something, maybe they need to encrypt something, they may need to deal with cryptographic information, or also with passwords, for instance. If you need to store, for example, the username and the password of your database user in order to access it, you need to put this information somewhere, right? And you've got a lot of different options available where to put this information. The first one is certainly hard coding. Just simply hard code it, private static string DB user, for instance. You can do that. Then it's shipped with the application. It's hard coded. You cannot change it also, of course. Then, alternatively, you can pass it in as a config file. The config file can be hosted by Kubernetes in terms of a config map, for instance. And then it gets mapped into a pod on starting the pod. And then you can use the config file from there with your credentials. Other option is that you pass it in as an environment variable. It's the same story. Again, you start a pod, you pass it into the pod via an environment variable, and the service uses it. Or you store it as a Kubernetes secret. You can also store it as Kubernetes secret, because the config files, which I was talking about before, and also an environment variable, I was assuming config files in the background. But you can also store it as a Kubernetes secret. And the Kubernetes secrets, they reside as a secret resource in the Kubernetes cluster, which I will talk a little bit about later. Or you read this information, your sensitive information, even from a vault. This is also an option, of course, that you've got a vault in place from which the bots then fetch all the secrets which you need, like, for example, passwords, cryptographic keys, etc. What are the pros and cons of these approaches? Hard coding certainly super easy to implement. It's the easiest way and also, I guess, the oldest way how to implement it. But it works. There's a drawback, of course, and it's hard to change and reverse engineering, and everyone who has access to the source code can see it. So there are also some cons, of course. Passing in as a config file, pro is certainly that the secret can rotate because you can change it. But you need to set up RBRC in Kubernetes, and the config files or config maps are not encrypted. Same is true for environment variables. Secrets can rotate. Here in that case, it can be read from memory in your running container. And you also need to set up, of course, role-based access control in Kubernetes, and also in order to make sure that your config maps are protected, which carry these environment variables. Then passing in as a Kubernetes secret. Again, secrets can rotate. That's good. And depending on how the cluster is configured, it may even be encrypted, which would be great, right? By default, unfortunately, it's not. So by default, if you use Kubernetes secrets out of the box, or if you really install it on your own, of course, cloud providers like AWS, for example, they provide encryption of the entire etcd database. However, if you run your own Kubernetes cluster, then this is not the case. And by default, Kubernetes secrets are only base 64 encoded. And this is, of course, an issue because then everyone who can read out this information can immediately see the Kubernetes secret, which you want to persist like a password. And the last option, of course, is reading it from a vault. As we said, this is the last option. The advantage is certainly that this is fully decoupled from the cluster. There exists a lot of software companies which just do that, and that's for a good reason. But on the other hand, it's a complex setup, of course, because this is much more complex to implement, much more complex to maintain. So from a recommendations perspective, I would say that hard coding is certainly a no. I would not consider hard coding secrets at all. Similarly, also not passing them in via config maps, so as a config file or as an environment variable, both boil down to config maps in the end, or potentially. And I would not consider that as implementation. Enabling or using Kubernetes secret for storing credential information is acceptable, but then in that case, you should set up encryption configuration, which is a resource of Kubernetes, in order to encrypt your secrets address, to encrypt your data address. But then it's acceptable if you set that up. And of course, recommended would be that you have a vault in place. This is certainly the most secure solution. So security-wise, the vault is the best. Okay, and how could it look like now? I mean, you've got your services, the services access a vault. You may even have then an access control list in place, which filters out the hosts which want to get access to the vault. And even in case that you have one of these services, you still need the secret in order to get the information out of the vault. So you can try to implement something along the lines like this and isolate this vault. Okay, summary. Let's wrap that up. What does really matter now for security nowadays, for microservice security? First of all, I would certainly say you need to protect your cloud environment. This was our starting point. This was our town. Next, we need to protect the communications. So we want to know who talks to who about what. And by that, I also mean external and internal communications. So you should even consider when you've got a Kubernetes cluster running and services need to talk to each other inside a cluster, that even there you put HTTPS in place and properly protect the communication along the services inside even, so the internal communication. Next, we were authenticating and authorizing. So this certainly matters a lot when it's about identity of users. So you should always authenticate and authorize your users, of course. And then also secure the pods and containers which you are running, because they are your applications and you should secure them. I've shown some guidelines how to do that. Of course, there would be much, much more, and I can certainly give an entire webinar just on Kubernetes security in general. However, I just wanted to give you a brief overview about the different countermeasures there which you could use in order to raise the security of pods. And for me, personally speaking, the most important part is certainly sanitizing input data, because I would say around 70% of all the issues which get identified, at least during my daily work, are due to missing input data validation, is not properly sanitized, is not properly cross-checked. And through that, you most of the time get really, really severe issues. So sanitize your input data, you know what kind of data you are getting, and validate it against your expectations. It's very, very important. And finally, hide your secrets. So if you've got a database connection string, put it into a Kubernetes secret, read it from a vault, put it somewhere where it's safe. And with that, I would like to thank you. This is the end of my presentation today. And of course, reach out to me. You see my email there on LinkedIn. I've also got a GitHub account, a GitHub repo where I usually put all the code article examples, so that all the code associated with it. Check it out, reach out to me, and stay secure until then. Thank you very much.
Thanks, Alex. That was awesome. So I'm assuming I shouldn't be using 1, 2, 3, 4, 5, 6 as my password. So I guess I'll have to do some change in there. But that was awesome. Thanks. That was really good. I'm sure there's tons of good information there for everybody. A couple of other announcements I want to kind of go through here is really would like you to complete the survey. They're important to us. We actually pay quite a bit of attention to the answers on these. Plus, you could end up winning a $100 Amazon e-card. There's the link. We've also putting that into the chat window as well. And don't forget to get that done by Friday to be eligible. Also, everyone's getting a free subscription to Code Magazine. Everybody who's registered for this event is going to get a free digital subscription. Here's that link to others who couldn't make it. If you could share that on social media, that would be awesome. We'd appreciate that. Join the code consulting team. We are hiring. So if you've got friends or you are looking for a new gig, we're looking for Python developers, React, C# developers, .NET desktop developers. So head out to our jobs page and take a look at what we have available. You need some free consulting, and it literally is an hour of free consulting on us. Reach out to me. We'll get a call scheduled. There's no strings, no commitment, no credit card. You're not going to get an invoice for this. It just gives you a chance to share maybe some of your questions or brainstorm some ideas with our team of experts. Happy to help you any way we can. Also, we've got some upcoming Code Presents, an upcoming Code Present webinar, not webinars, but webinar. Our next one is improving string handling performance in C#. That's going to be November 9th. There's the link to go ahead and register for that. We also have Stata.net, our next Stata.net webinar from our fearless leader, Marcus Edgar. He'll be talking about .NET 7 and what to expect and what to look for in .NET 7 when it releases in November. There's a link to go ahead and attend that webinar as well. Speaking of .NET 7, .NET 7 will be launched at .NET Conf, November 8th through 10th. We are a sponsor of that event. There's a link to it right there. If you're not familiar with .NET Conf, it's a free 3-day virtual developer event by Microsoft. They'll be launching .NET 7. They'll have tons of .NET content. It's a community event as well as kind of in concert with Microsoft. So the .NET Foundation plays a large role in running that. It's a great event. There's a ton of information, and that's why we choose to sponsor it every year. That is it for this event. Like I said, we ask you to hold off questions until the end, and now is the end. So if you've got questions for Alex in terms of security and the way to do things, or any questions you have about the slides or the information he presented, now would be the time to go ahead and get those into the chat window, and we'll try to get those answered. So we will take it from there, and I am done talking, I think. Good job, Alex. That was great stuff.
Oh, thanks a lot. Thanks a lot. Hope you enjoyed all.
Yes. Let's see what's in the chat window.
I just noticed
site,
that
I see one question. One question that just went by was, what was the site the article was mentioned? Codemag.com, Code Magazine. And if you take a look at the March-April issue of 2022, you'll find Alex's issue. I'm looking for if there's any other questions coming through for you. Here's one. How do you securely store secrets to access the vault?
Yeah, this is actually quite a tricky thing, to be fully honest. I mean, the best thing would be, of course, if you somehow build security based on the user. So, for instance, if a user enters a password and you keep that somehow in memory during runtime and you never persist it anywhere, And this you then use to access again the vault via some key derivations. That would be the best, of course. However, this is not always possible, and it's quite hard also to implement. So the best thing is, of course, if you have these secrets only in memory inside an application without ever persisting it, without ever seeing a hard disk. That would be the best. However, I know this is not always possible. So in that case, I would say one of the ways what it could go is certainly that you have at least the secrets for the vault. You put them into Kubernetes secrets and encrypt it with one of the key, with a safe key, so to say. And you set up a role-based access control with regards to these Kubernetes secrets in the most secure way, meaning that only admins have access to that. But I know it's quite tricky to implement that fully, because in order to really gain security, you would need to authenticate on the fly to the vault in a service where you don't have a UI, for instance. So I know this is quite hard, actually.
Cool, Larry. I hope that helped. Waiting to see if you have any other questions coming through. Alex, I'll ask a question. That 123456 password that I'm using for my bank account, I shouldn't be using that.
This you should not use, because but it's good to know. Thanks for letting me know. I've got some activity on the weekend now.
Maybe I'll change it to ABCDEFG. You'll find all of $4.22 in there. So, I think that translates to about the same in euro. So, you get about $5. Good luck. Cool. I'm looking to see if we've got any other questions coming through. Question here, a consultant might respond, it depends, but from the major cloud providers, is one more secure than the other?
To be fully honest, I would not really say that. I mean, they all have the pros and cons, I would say, and the entire infrastructure, the entire security concept is differing for each and every cloud provider. For instance, Microsoft Azure is building on a completely different security concept and completely different concepts than, for instance, AWS. These are simply completely different implementations of quite something similar, and they all have the pros and cons, I would say. But to really give a recommendation, I would not give a recommendation, to be honest, because for cloud security, it's also really with regards to cloud providers, I would lean myself a little bit too far out of the window in order to really give a recommendation. So I would say they are all quite similar in that sense. At least the topics which I talked about, they are independent of the cloud provider itself, because the majority of the talk was about the microservices itself, independent of where they run. So these are the things which I talked about. They are really independent of the cloud provider. You can apply this to any cloud provider.
Yeah, and that makes sense. That I mean, it's hard to make a recommendation, and I would think that all the major cloud providers are as secure as they can be. I mean, they got tons of people on staff who are doing nothing but doing security work.
Exactly.
So, yeah, it's when people I'll often talk to potential prospects for code consulting doing work, and like, well, we want to store our stuff on our local on-prem because we don't trust the cloud. It could be a security breach in the cloud. I'm like, really? I think they're spending a ton of money on security at Microsoft, Google, and Amazon on security. So I tend to stray from that idea. Let's see what else we have. The question from Chris Fox. Would you recommend cloud versus on-prem when discussing security concerns? I know that some clients have thoughts on cloud when you hear about cloud hacks exposing data.
To be fully honest with regards to this, I would say I have a quite clear opinion on this. Building security on your own, you need extremely highly skilled people which do that. It's not like, okay, you're gonna do a IT management 101 and now I know how to set up all the firewalls of the world. Unfortunately, that's not the case. So I personally believe that setting up all the infrastructure on your own, and especially that in a secure manner, in a secure way, this can be quite challenging. And to be fully honest, I'm not sure if this is always the right way to go. So it's very hard to get everything right. And to be honest, I think that the major cloud providers, they went through exactly this. They've got experts working 24/7 only on that topic. So I'm not sure if it's really a good idea to trying to build that on your own when you know the big cloud providers already went through that several of times. There were several vulnerabilities disclosed, and you try to build the same story over and over again. I personally believe that you should more go in the direction of cloud, to be honest, because getting it on-prem is really hard to get it right. You can get it, of course, true, fair enough, but getting it right is really, really hard.
And that's typically what I end up sharing with our potential customers and our customers on that topic. Here's a question from Bill Hyde. Can you comment on the Azure method of limiting access to an application with a registered identity?
To be honest, not really. No. I mean, having an application running in Azure, and you want to limit the access to it. I mean, what I would do certainly is at the level of an API gateway, for instance, I would introduce application tokens, so API tokens, by which you somehow filter out the applications which want to talk to your microservices, which want to talk to your backend, because this gives you actually two advantages. The first one certainly is that you make sure that only registered applications which you really trust in that sense can talk to your backend, to your microservices. You can bounce them back already at the API gateway level. However, it also comes with the advantage that you can even perform some custom routing, some custom validations, some role-based access control, etc., depending on your application. So this also is quite an advantage when it comes to security, that you can already distinguish at the level of an API gateway among different applications. I'm not sure if this answers the questions. However, this is at least what I know about that topic.
That makes sense to me. And there's a comment from Chris Fox. Maybe comment on why you would recommend cloud may be better. That's exactly what you did. We were talking about doing cloud versus on-prem.
Yeah, right.
Yep, good. We'll keep the chat open for a little bit longer here for any other questions you may have. Here we go from Tony. One aspect of security is that you have not addressed. What if one cloud provider decides they don't like your politics and shut your account down, leaving you high and dry?
Yeah, against this you can't protect, unfortunately. If the cloud provider takes you down, I mean, if you've got a running application inside a cloud, of course you are dependent on the cloud provider. I mean, this is quite natural. So in that case, if you don't have any failover strategies, any recovery strategies from having a full failover from a cloud provider, then of course, in case a cloud provider shuts you down, then you are out. I mean, this is as simple as that. However, and this I have to say, the situation is not that bad actually, since most of the time you've got everything in place already and everything configured in such a way that it runs in Kubernetes most of the time. And this is the most valuable part of your application, I would say, apart from the database. Of course, the database, you would need to create a backup strategy that you also have some physical replicas of your data. But given the promise that you've got a physical replication of your datasets, plus you've got all the source code of your services available, which you can run, and it is built on top of Kubernetes and Docker, then the switch is quite easy, I would say, from a cloud provider either to one provider to another one, or even to say, okay, I host it on-prem. Since it builds on Kubernetes, you can run it basically everywhere. And in that case, you are quite prepared for that, I would say.
Yeah, I often wonder the benefits of having, say you're running in cloud provider 1, having it also configured in cloud provider 2, just in case. You never know if cloud provider 1 goes down, you flip the switch, you're over on cloud provider 2.
Yes, exactly.
I mean, it's extra work, extra infrastructure, but it's still work to do. Let's see, from Eric, here's a question. Is there a migration path between Azure and AWS or back again?
To be honest, I'm not fully sure, but I think so. That you can really can convert between those two quite easily, because you can also build the entire cloud infrastructure in Terraform, for instance, which is quite provider agnostic at least. However, there are some provider packages. So I think it is straightforward to do. Of course, you need to identify what the component maps to what in the other provider. I'm not sure if there is a standardized way how to do that, because I was not really looking into changing the cloud provider, to be honest. So I believe it's straightforward to do, but I'm not fully aware of an official migration path. About this, I'm not aware of. Maybe this exists, but I'm not fully sure, to be honest.
Got it. Let's see. Good point there, Bill. Bill Hyde says maybe code needs a presentation on cloud services to include security methods and migration ability. That's probably not a bad idea. And we, Eric, I like your answer. I think we probably have Alex do it. That makes sense to me. That makes sense to me. Any other questions? We'll give y'all a few more minutes. I know I type slow. So we'll do a couple more minutes here, see if we get any more questions about security for Alex, and we'll take it from there. Give you a few minutes. Let's see.
Sorry also for the small text box, which I did not hide. I did not notice it, to be honest.
Don't worry, and we've already commented that for that little text box, whatever that was blocking any of his slides, the slides will all be available for download from the Code Presents page, and the slides will all be, they're all created before the presentation. So anything that's blocked won't be obscured in the slides. So we should be good to go there.
This was just a security technique. It was obfuscation.
Yes, that's what you were doing. That's what you were doing. I like that. You were trying to hide things. You're trying to obscure things as a security guy. Put stuff on your slides to block it. Yeah, I like that. That works. That's the vault. That's the vault. Exactly. The vault works.
Access the secrets.
So here's a question from Claude, and this is, I don't think you're going to have an answer to this one. Can you do microservices with Visual Fox Pro?
For this, I unfortunately do not have an answer, but I don't.
Exactly. Neither do I, Claude. I can certainly try to get an answer for that, because we do have a bunch of Visual Fox Pro developer resources here that I can reach out to and get an answer for that. If you want, Claude, you'll find in the slide deck and in the beginning of the presentation my email address. There it is. You can just send me an email at jduffy@codemag.com, and I can certainly get you an answer, Claude, about doing calling microservices with Visual Fox Pro. And India, it looks like you might be answering, saying it's called infrastructure as code. That way you can migrate your stuff anywhere you want. That's probably going back and forth between Azure and AWS. Infrastructure as code, where you just pick it up and move it around, like you're talking with Kubernetes and Docker and containers. Just moving those things around between cloud providers makes it a whole lot easier to change cloud providers if you go with a container strategy like that, and then the cloud provider becomes less and less important.
Exactly.
Cool. All right. Well, we'll see what kind of other feedback we get here in the chat window in the next minute or two, and if not, we will let you go, Alex.
Okay.
Awesome stuff. Appreciate you doing that for us. Always enjoy hearing stuff about security. You can never hear enough about security. Although you've now leaning me toward changing my password from 1, 2, 3, 4, 5, 6.
You should consider it. But please don't change it before Monday next week.
Yeah, nice. I might switch it over to something like secret or password, because I'm clever. I'm very clever.
You're smart. You've got 8 characters. Raise the complexity.
Password 1, 2, 3. No one will ever figure that out.
Oh my God.
No one will ever figure that out. Okay. I think that's about it. I don't see any other security questions coming through. I saw Claude has an answer about helping using .NET code to call VFP code, or a class library. But these are just the responses back to Claude's questions about Visual Fox Pro. Okay, I think I don't see any more security questions coming through. We'll give it another 15 seconds. If you have a question, say, I have a question, and hit enter, because we're going to drop off here shortly. If you got a long one to type, we will definitely hang around if you've got a long question to type. But if not, we'll go ahead and jump off. But again, Claude, if you've got a question, or anybody has a question about things that we provide, can we answer Visual Fox Pro questions? Can we talk about helping you migrate your applications from any legacy technology into something modern? We can certainly help with that. My email address is on the slide there. We migrate a lot of applications from a lot of different legacy platforms, so we're certainly happy to help. I think I am going to call it because I see a lot of, good presentation, good stuff. I don't see any more security questions coming through, so I'm gonna let Alex go. All right, that's I'm gonna count down from 3, 2, 1, done. All right, see, I called it. That's it. We'll go ahead and shut this down. I appreciate everybody coming. Thank you again, Alex, for giving us an awesome presentation on secure microservices. And until next time, we will talk to you all later.